Hello everyone, and welcome to this video on solving equations involving two absolute values. So in this video we're simply going to be looking at several examples of equations in which one side of the equation has the absolute value of some linear expression, and so does the other side of the equation has the absolute value of a linear expression. Right? So you're not going to see any variables with powers, exponents higher than 1 in this particular video. Alright, so let me begin. In each example, I'm simply asked to solve the equation, right? Solve each equation here. And as I mentioned a second ago, what we're looking at are equations of this type with two expressions inside absolute value symbols on both sides of the equation. So I have the absolute value of x minus 3 equals the absolute value of 2x plus 5. And we're trying to figure out what number or numbers I could replace the x's with to make a true statement. Alright, so let me go over here real quick and talk about these types of equations where I have the absolute value of some expression, which I'll just call a, on one side of the equation being equal to the absolute value of, and then another expression which I'll call over here b. Right? So every equation we see in this video will take on this form. Well, let's think about when two numbers have the same absolute value. Right, let me actually ask that question, because any expression represents a number. Right? X minus 3 represents some number. 2x plus 5 represents some number. It all depends on what value x takes. So over here I have these expressions, these numbers a and b inside the absolute value symbols, and the question is, when is the absolute value of two numbers, or when are the absolute values of two numbers equivalent? Or when is the, actually is the, right, when are, I'll just say when are the absolute values, right? When are the absolute values of two numbers, in this case a and b, equivalent? All right. So let me just show you a few examples with some actual numbers. The absolute value of, say, 4. Remember, absolute value, when we're dealing with just real numbers, you can think of it as the distance from 0 on the number line. Right? It's always non-negative, right? Never negative. The absolute value of 4 is equal to positive 4. Right? And so is the absolute value of negative 4. Right? That is also equal to positive 4. So if two absolute values are equal, here I'm saying that the absolute value of 4, right? So the absolute value of 4 is equivalent to the absolute value of negative 4. So that gives me one case, an example of one case where two absolute values are equivalent, and that one case is when the numbers inside are opposites. Right? That says opposites. 4 in here, negative 4 in here, but taking the absolute value of them, they are the same. They're both equal to positive 4. So that's one case when the absolute value of two numbers will be equal, is when those two numbers are opposites. And then the only other one I can really think of, and I can show you here, is the absolute value of 4 is obviously equal to the absolute value of 4, right? They're both equal to 4, right? And two absolute values will be the same when the numbers inside are the same, right? And these are really the only two cases that come up here. All right, so so going back to this, my initial statement up here, when is the absolute value of a equal to the absolute value of b? When either a and b are the same, or A and B are opposites. So A equals, the opposite of B, or negative 1 times B. And this is key right here. This is how we're going to solve these equations involving two absolute values. We're going to start off with the equation having two absolute values, and then we're going to write this equivalent statement. Saying this is exactly the same as saying this statement in the cloud here. It's saying that either the two expressions are equal or they're opposites. And we solve these and, of course, check our solutions when we are done. So in my example here, I have, the absolute value of x minus 3. So this x minus 3 is like the A equals the absolute value of 2x plus 5, and the 2x plus 5 is like the B. Alright, so this is equivalent to saying when are two absolute values equal? Well, one case is when the expressions inside are the same. So when x minus 3 is the same thing, the same number as 2x plus 5, well then they would have the same absolute value. Or when x minus 3 is equal to the opposite of 2x plus 5. So that's, negative 1 times this whole thing, right? The opposite of, now this is not absolute value, this is parentheses, and probably should have written this somewhere else, 2x plus 5. Alright, sorry about the little arrow getting in there, but so when they're the same, they'll have the same absolute value, or when the expressions, the numbers, are opposites, and we'll have to distribute the negative here, right? I'm taking the opposite of that entire 2x plus 5. Alright, so I set that up, and then we're going to solve each equation and, of course, check our solutions back in the original. Solve each equation and, check solutions in the original equation. Always in the original when you're checking solutions, the way it started off looking. Oops, not G, Q. Alright, so I'll do that on a separate page here. So we have this one equation to solve. Right, when the two expressions, the two numbers inside are the same, they'll have the same absolute value. So x minus 3 equals 2x plus 5, and we're trying to figure out what value of x would make this happen. And as I mentioned at the beginning of the video, these are going to be just linear expressions, a nice linear equation. So I'll gather all the terms with x to one side, so I'll do that by taking away x. That'll give me all the x's on the right, and then take away the 5 over here to take all the terms without x to the left. And if I do this, you have nothing there, and then negative 8 left over on the left side, and then 2x minus x makes 1x on the right, and the 5 minus 5 is 0. So there's a possible solution, negative 8 for x. Or another possible solution can come from this other equation where the two numbers inside, the absolute values of the two expressions inside, are opposites, right, where x minus 3 is the opposite of the quantity 2x plus 5. Again, notice no more absolute value symbols. I'm rewriting it as a statement that doesn't have absolute value symbols. And you'll notice that in a lot of equations that have special symbols in them, like absolute values or square roots. The key to solving equations with special symbols is to eventually get them rewritten as a statement without that symbol, and go from there, and of course check your solutions. Alright, so here I'd be distributing the negative 1 to the 2x plus 5 first, and taking the opposite of 2x plus 5. So the left side still x minus 3, and then when I distribute the negative 1 here, that's negative 2x minus 5. And then I'm going to take all the x's to the, now this time, again, I like having a positive coefficient on variables I solve for when we're dealing with a linear equation. So I'm going to add 2x, right, get rid of this negative 2x on the right here and do the same thing to the other side. And I'll take all the x's to the left, and that means I don't want this negative 3 over here, so I'm going to add 3 and do that to the other side as well. Alright, so then we have x plus 2x, that's 3 times x on the left. Negative 5 plus 3, it's negative 2 on the right. And then finally, dividing both sides by positive 3, I get this other possible solution, x equals, negative divided by positive is negative 2/3. Alright, and again, keyword being or here, we have to check, is this a solution, or this could be a solution, or both of them, right? Usually when you see or in a math statement, it is the inclusive or, meaning one or the other or both. Alright, so let us check now. So again, here's the original equation up here. Let us check our solutions. So the first is x equals, negative 8. So I have the absolute value of, negative 8 minus 3 on the left, replacing x with negative 8, right, equals the absolute value of 2 times negative 8 plus 5 on the right. Now, please be careful. When you have absolute value symbols, it's like grouping symbols, it's like parentheses or brackets. You must simplify what's inside first and then take the absolute value. I find too often that people tend to see the absolute value symbols and then just, oh, everything becomes positive, make all the minus signs plus signs. That is not how it works. Right? You can't just go term by term and making everything positive. You get it down to a single term, simplify what's inside first, and then take the absolute value. So the left side is the absolute value of, negative 8 minus 3 is negative 11. The right side, 2 times negative 8 is negative 16. And then negative 16 plus 5 is negative 11. And indeed, these are the same thing. You get 11 equals 11. Yes. Right. So negative 8, I'll circle it up here. Negative 8 is a good solution to our equation. It makes it a true statement. You get 11 equals 11. Alright, now let me check the other one. Negative 2/3. Alright, so on the left side I have the absolute value of negative 2/3, then minus 3, equals, and on the right side the absolute value of 2 times negative 2/3, then plus 5. Alright, so when I simplify this here, now remember, when you add or subtract, you need a common denominator, right? So I can't put these together right now, negative 2/3 minus 3. But if I change 3 to, multiply the numerator and denominator by 3, that'll be 9/3. So negative 2/3 minus 9/3, this is the absolute value of negative 11/3. Alright. And the same thing here, now you can multiply, you don't need the same denominator to multiply, you can just multiply the numerators, multiply the denominator. So 2 times negative 2/3, this would be negative 4/3. Then when you add, you need a common denominator, right? So negative 4/3 plus 15/3, right? You multiply 5 by 3/3. So negative 4/3 plus 15/3, that'd be positive 11/3. So I have the absolute value of positive 11/3, and are these the same? Well, yeah. The absolute value of negative 11/3 is 11/3, and the absolute value of 11/3 is 11/3, and these are the same value on both sides. So yes, negative 2/3 is also a valid solution to our original equation, this one right here. Great. So I went through and set up an equivalent statement. The two expressions are equal, the two numbers inside are equal, or the two numbers inside are opposites, set up an equivalent expression without absolute value symbols, solved each one, and then checked back in the original equation. Something else you might be asked to write too is called the solution set of an equation. So yeah, I've circled them, but you might also be asked in some texts to write out the solution set of an equation or of an inequality sometimes. And it's just a set, right? So little curly braces starting off a set here. And it's just a set with these two numbers in it, right? -8 is a solution, comma, -2/3 is a solution. I just simply list the solutions in here and close the braces, close the set. So you might see the solutions written out in a set like this, but these are the numbers that when plugged in for x make my statement true. Alright, so again, the big takeaway from this one is this here. When we see two absolute values equal to one another, when are the absolute values of two numbers equal? When they're the same number, or when they're opposite numbers, right? So we set up this equivalent statement, A equals B, or A equals the opposite of B. Solve those, check your solutions. Alright, so I've got just a few more here, a few more examples like this, very similar. I'm going to be doing the same stuff. So my next example has a different variable. The variable's z instead of x. We have the absolute value of 8z plus 11 equals the absolute value of 6z plus 17, but it's no different than my previous example. I'm going to be doing the same thing. This statement involving the two absolute value symbols is equivalent to this statement. When are the absolute values of two numbers equal? When those numbers are the same. So either when 8z plus 11 is the same number as 6z plus 17, or they'll have the same absolute value when they are opposites, right? When 8z plus 11 equals the opposite, right? So -1 times, and then this is parentheses, not absolute value, -1 times the other expression, times the quantity 6z plus 17. Right, so when the numbers are the same, or the two numbers are opposites, they'll have the same absolute value. All right, and then we solve each of these. All right, so the first one, I'd take away 6z from both sides, and then also take away 11 to get all the z's on the left and non-z's on the right. Gives me 2z on the left equals 6 on the right, 17 minus 11. Divide by +2, and I'm getting one possible solution is z equals 3, right? And then we get another possible solution over here. And so either this one or both could be solutions to this equation. Taking the opposite of 6z plus 17, we have 8z plus 11 equals -6z minus 17. All right, and then again I'll take all the z's to the left, so I'm going to add 6z to both sides. I'm going to subtract the 11 from both sides, and that gives me on the left side 14z equals, and then -17 minus 11 is -28. And then dividing by 14 to get z alone, get z equals, and negative divided by positive is negative, and 28 divided by 14 is 2. Alright, so two possible solutions, and let us not forget to check them. Alright, now these I'm just going to kind of say out loud instead of writing it out. So how about let's check z equals 3. Replace z with 3. Alright, so on the left side, 8 times 3 is 24, plus 11 is 35. I have the absolute value of 35, which is 35. I'd have 35 on the left equals, and then on the right, 6 times 3 is 18. 18 plus 17 is 35, and the absolute value of 35 is 35. You get 35 equals 35. Yes, 3 is a good solution. It does make that a true statement. All right, how about negative 2? When I replace z with negative 2, 8 times negative 2 is negative 16. And negative 16 plus 11 would be negative 5, but then you're taking the absolute value. So the left side is positive 5, right, the absolute value of negative 5. Replace z with negative 2 on the right side. 6 times negative 2 is negative 12. Negative 12 plus 17 would be positive 5, and the absolute value of positive 5 is positive 5. I get 5 equals 5. Also a true statement. So negative 2 is indeed also a solution of this equation. All right, and then one more time here, I won't do this for the rest of the examples, but one more time we could also then state that the solution set of this equation is the set with the numbers 3 and negative 2 in the set. As another way to write the solutions, only these two numbers make this statement true. Alright, wonderful. But the same procedure each time. Two absolute values will be equal when the numbers inside are the same, or when the numbers inside are opposites. You solve and check. Right, so my next example is another one where the variable different again, but the variable being different doesn't mean anything. This could be x or z or t, but it's y this time. The variable's y. So I have the absolute value of 3 minus 2y equals the absolute value of 4y plus 3. So as with the last two examples, this statement, I'm going to rewrite it as an equivalent statement involving the word or and no absolute value symbols. Right. This statement that we started with here with the two absolute values, this is equivalent to the following statement. When are the absolute values of numbers equal? When those numbers are the same, right? So when 3 minus 2y equals 4y plus 3, they'll have the same absolute value. Or when they're opposites, so when 3 minus 2y is the opposite of, and again parentheses here, the opposite of the whole thing. When 3 minus 2y, this number is the opposite of the quantity 4y plus 3. Alright, so I've set up an equivalent statement, with no absolute value symbols. Got rid of those. Then we solve and check. Alright, so this equation here, like I said, I like to have positive coefficients on my variables. So I'm going to I'll add 2y to both sides, take all the y's to the right, and then take away 3 from both sides. That leaves me with 0 on the left equals 6 times y on the right. Then dividing by 6, you're going to see y is equal to 0. Alright. 0 divided by any non-zero number is 0. Alright, so 0 is a possible solution, or then solve this equation over here. When they're opposites, distribute the negative 1. So we have 3 minus 2y on the left equals negative 4y, and then minus 3 on the right. And then to get all the y's to one side, this time I'm going to add the 4y to both sides. That'll put y terms on the left, and to get this term away from the left, I'll subtract 3. Alright, so that gives me negative 2y plus 4y is positive 2y equals, and then over here the y's are gone, and negative 3 minus 3 is negative 6. And then dividing by positive 2 on both sides, you get y equals negative 3. Alright, so 0 or negative 3 or both could be solutions to this equation. Let us check them. Alright, so check your solutions back in the original equation, and again I'm just going to write the final results of the sides. I'm not going to go through the whole thing. When y is 0, replace y with 0. You'd have 3 minus 2 times 0. Well, 2 times 0 is 0. 3 minus 0 is 3. And then you're taking the absolute value of 3. So the left side would be 3. And then again, replacing y with 0. 4 times 0 is 0. Plus 3 is 3. And then again, you have the absolute value of 3. You get 3 equals 3. That statement is a true statement. So again, we have a solution. 0 is wonderful. 0 works. Makes it true. Try the other one. Y equals negative 3. When I replace y with negative 3, here I have negative 2 times negative 3 is positive 6. So this is 3 plus 6, or 9. We'd have 9 in here, and the absolute value of 9 is 9. Okay, so I'd have 9 on the left. And then when y is negative 3, over here, 4 times negative 3 is negative 12. Negative 12 plus 3 is negative 9. But again, we're taking the absolute value. The absolute value of negative 9 is positive 9. And indeed, 9 equals 9. That is a true statement. So once again, I have a valid solution to my equation. Great. And again, if you want to write out the solution set is the set with the numbers 0 and negative 3 in it, go ahead. But that's it. Those are the solutions. Those are the numbers I can replace y with and make a true statement. All right. Now I have one last example. Hopefully we come across some different scenario here. So far every single example I've shown has had two solutions going through this process. Let's see if that happens for this last one. I'm going to do the same procedure. I'm still doing the same stuff. We're back to the variable x now. So I have the absolute value of 2x minus 3 equals the absolute value of 5 minus 2x. And again, when are the absolute values of numbers equal? When they're the same or when they are opposites. So this statement here with the two absolute value symbols is equivalent to the following. When they're the same, the absolute values will be equal. So when 2x minus 3 is equal to 5 minus 2x, right? Or when these numbers inside the absolute values are opposites, the absolute value will be the same. So, or when 2x minus 3 is equal to the opposite, so again, negative 1 times, and then the other number, 5 minus 2x, the quantity 5 minus 2x. Okay, so just like all the other examples, I set up an equivalent statement involving no absolute value symbols, and then I solve each of these and we'll then check our solutions. Alright, so for this first equation here, I'd be adding 2x to both sides. Alright, that'll take all the x terms to the left. So I want to get rid of this negative 3 on the left and add 3 to both sides. Gives me 4x on the left equals, and then 5 plus 3, 8 on the right. Divide by positive 4. So we're getting a possible solution here of x equals 2. Or, and then this other equation, alright, you're going to see in a second here, this other equation will not provide me with any additional possible solutions. Let's check it out. So this is 2x minus 3 equals, the opposite of 5 minus 2x. I'm going to distribute that negative 1. And we have, 2x minus 3 still on the left equals, and then negative 5 plus 2x on the right. Alright, so look at what happens, right? In this case, either way, no matter what I do, I'm going to have to subtract 2x if I want to take away the x's from one of the sides, right? So I'll subtract 2x, and I'll just add 3. Let's say I'm taking the x's to the left, I'll add 3. Whatever, right? Well, look at this. That's gone. The x's, that's gone. So I have 0 on the left equals, and then over here the x's are gone too. 2x minus 2x is nothing. Negative 5 plus 3 is negative 2. And I get down to this statement, 0 equals negative 2 here. That is what they call a contradiction. Alright, something that is false. Right? It contradicts what we know about real numbers. Right? We know that 0 is not equal to -2. So this contradicts that. And because of this, this equation, right, this equation on the right, has no solution. Right? No matter what you plug in for x, this equation will never be true. This equation will be, right, when x is 2, this is a true statement, you can check it out. But this equation, and you'll see that whenever solving equations or systems of equations, if you ever end up with a contradiction like this, something that goes against what you know about the real numbers, like 0 equals -2, or -3 equals -5, 1 equals 7, stuff like that. If you come across a contradiction, that implies that that equation, or even that system, if you're dealing with systems, has no solution. So this equation, right, just this one, not the original one, just this one on the right, this equation has no solution to offer. Okay? So now when we go to check our solutions, there's only one to check. When we go to check our solutions, right, I'm not getting any from this second one. Nothing from here. The only solution that this equation could possibly have is the number 2 from this first equation. So I plug in 2 for x, and let's see what happens. On the left, 2 times 2 is 4. 4 minus 3 is 1. Absolute value of 1 is 1. I get 1 on the left side. And then when I plug in 2 on the right, 2 times 2, or -2 times 2 is -4, and then 5 minus 4 is 1. Absolute value of 1 is 1. You get 1 equals 1. That is totally a true statement. So x equals 2 is the only solution to this equation. Right, so if I were writing out that solution set again for this equation involving 2 absolute values, it's the set with only the number 2 in it. And you could write it like that. Okay, so this one was just a little trickier because of this one possible equation where the equation had no solution, but still the other one provided us with something. But it was a little different though, right, than the first 3 examples. The first 3 examples, every equation had 2 solutions, but this equation here only has 1 solution. And you may even come across scenarios where there are no solutions, but not going to get into that. You'd still do the same procedure, set up this equivalent statement with the word or and no absolute value symbols. You solve each one of them, and if you check both of them, if you check if you have some solutions and then you check them back in the original equation and they don't work, well then that tells you the equation has no solution. Right? But that didn't happen in any of these examples. But I'm just warning you, it could in the future. Right? So keep an eye out. Always check your solutions back in the original statement. Okay. So as I like to say at the end of these videos, please try your best, do the best you can to try and learn and understand the material on your own before you go looking for help. As I find that people who put in the time and the effort to learn things on their own, the material tends to stick with them longer and they tend to remember it better than people who seek help immediately and just give up right away. So read the material, of course. Read the author's examples. Perhaps even work on the solutions to an author's examples before you look at how the author did it. And then compare your work with the author's work afterwards and see if you can learn from any mistakes there. And obviously, do plenty of exercises, practice problems, and check solutions to them whenever they're made available. See how you're doing. And don't give up on a problem after just one attempt. Very often there are several ways to approach a problem in mathematics. So if after several attempts at a problem, several different approaches at a problem, you're still not getting it, still not making sense to you, perhaps you should go back and read the material again. Perhaps more slowly, deliberately, take notes. Because if you've done some problems too, you'll probably have a better idea working on those problems as to what the author is expecting of you. And with that in mind, maybe a second or third, even third read through of the material will bring some things to light that you didn't see in the first place. Some things will catch your eye or make more sense the second or third time through the material that didn't the first time. But if after that, if after several read-throughs of the material and several attempts at problems, you're still not getting it, it is not a sign of weakness whatsoever to go out asking for help, looking for help. That is what other people are there for. So ask a teacher, a tutor, a friend, someone in your class who you know knows the material well and is willing to help. Look for supplemental materials online. There's tons of it out there. Look for videos on the subjects. There's loads of those as well. On math, you can very easily search for them, like this one, or plenty of other videos out there that are better than the ones I'm putting out. I promise you can find them. But just keep at it. Stay persistent. Keep practicing. Don't give up. And I think the hardest thing of all is to keep a positive attitude. Thinking that you're going to hate something or thinking that it's going to be boring or that you've always hated it isn't a way to go through things. You're going to continue to hate it, and it's going to continue to be boring to you, and you're not going to have a very good learning experience. Now, I know it's easier said than done, but try to have an open mind. Try to say to yourself, I'm going to read this material, I'm going to practice these problems, I'm going to enjoy doing it, I'm going to take away something from it and learn something today, and I'll be all the better for it. And stay positive. So, stay persistent, keep practicing, stay positive, and don't give up. And I just know you'll get it. And thank you very much for watching.